Welcome back to my channel. Today we are going to look at how you can implement the abstract factory pattern in Python. The abstract factory pattern is a creational design pattern that provides an interface for creating families of related or dependent objects without specifying their concrete classes. The abstract factory pattern is also known as a factory of factories. If you haven't watched my other video on the factory pattern, then I advise you to do so. You can find a link in the description of this video. It is now time to code the abstract factory pattern. So here in VS Code, I've again gone and opened up an empty folder called Abstract Factory Python. So again, go ahead and hold Ctrl Shift and P and then select Create Environment. Then go ahead and select a virtual environment for your current workspace, and I'm going to select venv. Also select the interpreter. I'll go for the global one again. Now, the best thing to do is to start with the abstractions. In other words, our abstract products, and then our abstract factory, and then we can create the concretions thereafter. So let's start with abstract product A, which is our language interface, or in our case, our language abstract base class. So let's create a new file and call it language.py. Let's import ABC and the abstract method from the ABC module. So from ABC, import ABC, abstract method. And then let's mark this as our abstract product A. Then we can say class language, and then it needs to extend the abstract base class ABC. And then, as you can recall, we only have a single method for our abstract product A, and that is a method to greet somebody in a certain language. So let's define an abstract method with the abstract method annotation, and we will simply call it greet, and it won't take in any specific method arguments. The greet method will return a string, and since this is an abstract method, it'll not have a method body, so simply say pass. That's all we have to do. So let's go ahead and create our abstract product B. Create a new file and call it capital city. We can do the same from ABC, import ABC, abstract method. This is our abstract product B, so let's mark it as such. And then we can say class capital city, extend ABC, and this time we have two abstract methods that we need to define, one for getting the population and another for listing the top attractions for a given capital city. Both will be abstract methods, so again use the abstract method annotation. We can say get underscore population for the first one, and this one will return an int. Let's say pass, because the concretions needs to implement these methods. And then let's create another abstract method and call it list top attractions. The list top attractions method will return a list. And again say pass. Okay, so now we have both our abstract product A with a greet method and our abstract product B with a get population and list top attractions method. Then let's create our third and final abstraction, our abstract factory, which we'll call international factory. So let's create a new file and call it international factory. This too will be an abstract base class. So again, from ABC, import ABC, abstract method. And as you can recall from the class diagram, it'll have two methods, one for creating language and another for creating the capital. Basically methods for creating each of our abstract products. Therefore, we need to import our language class from the language file. And we also need to import our capital city class. So from capital city, import the capital city class. And then let's mark the international factory as our abstract factory. We can say class international factory needs to extend ABC because this is an abstract base class. And then we need to define two abstract methods. So again, let's use the abstract method annotation. And then our first method will be called create underscore language. It'll return our abstract product A, which is our language base class. And then let's define another abstract method. This one will be called create capital. It'll return our abstract product B, which is our capital city base class. Okay, so now we have implemented all of our abstractions, including the abstract factory and both our abstract products. Next, let's go ahead and create our concrete product A1 and concrete product A2. And that is the concrete classes for the language abstract base class. So let's create our first concrete class and call it English. So create a file called english.py, and then let's import the language abstract base class from the language file. And let's mark it as concrete product A1. Then class, its name is called English. It extends language. And therefore we need to implement the abstract method, the greet method. And we are simply going to return a greeting in English, and we'll keep it simple. We'll say that the way that you should greet somebody in English is hello. Now we can do similar for the Spanish class. So let's go ahead and copy everything, create a new file and call it spanish.py. I'm going to paste everything there and simply change the class name to Spanish, mark it as concrete product A2. And then let's say to greet somebody in Spanish, you say hola. So now we have completed the implementation of both our concrete product A1 and concrete product A2. Next is concrete product B1 and B2. So that is our capital cities. So firstly, we've got London as the capital of England. So create a new file called London. The London class will extend the capital city base class. So let's import the capital city class. From capital city, import capital city. Let's mark it as concrete product B1. And then the class name will be London, extending capital city. And therefore we need to implement two abstract methods, including the getPopulation method and the listTopAttractions method. So let's start with the getPopulation method. At the time of the recording, the population of London was 8.9 million. So let's go ahead and return 8.9 million. Then let's also implement the listTopAttractions method. And we can say that the top attractions in London are Tower Bridge, Buckingham Palace, and Big Ben. Okay, so we've completed the implementation of our London concrete product B1 class. Let's copy everything there. And then let's go ahead and create a new file and call it Madrid.py, Madrid being the capital city of Spain. I'm going to paste everything there. Let's change London to Madrid as concrete product B2, also extending the capital city base class, and the total population for Madrid at the time of this recording was 3.2 million. And for Madrid, we've got different top attractions. The first one being Royal Palace. The second one there, Prado Museum. And our third top attraction there is Retiro Park. So now we have completed the implementation of all of our concrete products. Next up, we need to implement our concrete factories. So let's start by implementing our England factory, our concrete factory 1. So create a new file and call it England_factory. Importantly, it'll extend the international factory. So let's import that. It'll also return the concrete product A1 and concrete product B1. Therefore, let's import English, our English class, from the English file. And then we also need to import London as our capital city, our concrete product B1. Let's mark it as concrete factory 1, and then class England factory that extends international factory. And therefore we need to implement both of the abstract methods, starting with the create language method. And we'll say that if the create language method is invoked on the England factory, we will return English, our concrete product A1. And we'll also implement the create capital method. And if the create capital method is invoked on the England factory, we'll return London as the capital city, our concrete product B1. So now we have completed our concrete factory 1. Let's create our concrete factory 2. And it'll be called Spain factory. So create a Spain factory file. Now we can go ahead and copy almost everything from the England factory and change some of the imports and some of the class names there. So we won't import English but Spanish from the Spanish file, and we won't import London but rather Madrid from the Madrid file. And then we'll say this is concrete factory 2 and it is called Spain factory. So when the create language method is invoked, we'll return Spanish as our concrete product A2 and Madrid as the capital city as our concrete product B2. Okay, so we've now completed the implementation of all of our concretions, including the concrete products and concrete factories. So next up, we'll go ahead and create our client logic, and that'll be in a main file. So go ahead and create a main file. So in our client code, we will invoke the create language and create capital methods on the concrete factory. So let's go ahead and import them from England factory. Import the England factory class, and from the Spain factory, import the Spain factory class. Then we can mark this as our client code. And let's define a main method. Then let's start by instantiating the England factory. So create a factory variable and say England factory, a new instance of England factory. Now our England factory can actually produce two types of products, and that is a language product and a capital city product. So firstly, we want to get the language. So say language equals factory dot create language. And then we also want the factory to produce a capital city product. So we can say capital underscore city equals factory dot create capital. And then let's print out our results. So I'm going to use a formatted print, and we want to start off by printing out the language that we're talking about here. So let's say language, and then we can get the language by saying language dot underscore underscore class dot underscore underscore name. In other words, if the England factory returns English, we can get the class name English and print that here. Next, we want to greet somebody in the given language, and we want to see what that looks like. So again, a formatted print, and we'll say greet, and then pass language dot greet. Next, let's print the capital city. So it will look similar to where we print the language. So we'll say capital, and then the capital city class that's returned by the factory dot underscore underscore class dot underscore underscore name. Okay, so we've got the language, the greeting, and the capital. We also want to print out the total population of the given capital city, and therefore we'll say total population, and then in curly brackets we'll say capital city dot get population. We also want to get the top attractions, so we can say top attractions and then invoke the list top attractions method. Okay, and then to make sure that this main method gets called on the startup of our Python application, we can say if underscore underscore name equals underscore underscore main underscore underscore, and that is the startup argument for any Python application, and then we'll invoke main. Let's test our code. We can do so by opening up our terminals and then typing Python 3 and then running our main.py file. And as you can see there, the language is English. The English way of greeting somebody is hello. The capital city of England is London. The total population of London, 8.9 million. And the top attractions are Tower Bridge, Buckingham Palace, and Big Ben. So to test the Spain factory, we can simply change the invocation of England factory to Spain factory. And then let's run it again. And as you can see there, language Spanish. The Spanish way of greeting somebody is hola. The capital city of Spain is Madrid. Total population 3.2 million. And then the top attractions are Royal Palace, Prado Museum, and Retiro Park. Now, if you look at this code, you might say you don't like this hard coding of the concrete factory there. And I absolutely agree. Fortunately, there is another approach that they call the provider approach. And you'll see just now that the definition where we say an abstract factory is a factory of factories will make absolutely sense when you see the provider. So let's go ahead and create a new file and call it international provider. Now, the international provider will be a factory method. It will in fact look just like the factory method that we created when we coded the factory pattern. And therefore it also needs a factory key. So before we implement our international provider, let's go ahead and create an enum class that we will call country. So go ahead and create a new file and call it country.py. So let's start by importing enum. So from enum, import enum. And then we can say class country that extends enum. And then we can define our enum values. And we want one for England equals 1. And we want another for Spain. And Spain will have a value of 2. Okay, so our country enum will now be our factory key. So let's start by implementing our international provider. So the international provider needs access to the enum, our country enum. So let's import that. It also needs access to both our concrete factories. So we need the England factory, import the England factory class. And we also need the Spain factory, so go ahead and import the Spain factory class. We also need our abstract factory, that'll actually be the return type of its factory method. So also import international factory. And we can mark this as our provider. Let's call it international provider. It'll have a static method. Remember that factory methods are generally static methods, and that's perfectly okay because it actually returns a new instance of a given concrete class. So let's define a method that is called create that takes in our factory key, which is our country enum. So country of type country, and it will return our abstract factory, which is international factory. And then we'll use a match case. We'll match on the country value, and we'll say that case, the country is England, will return a new instance of England factory. Case it is Spain, will return a new instance of Spain factory. And then if we don't have a case for a given country value, let's raise a value error. So case underscore, and then we'll raise a value error and say something like country is not currently supported. So that is all we have to do for our provider. So if we go back to our client code, we can now say, let's create a country variable, and we can set that to something like country.england. Now we need to go ahead and add the import, and I'm going to use this quick fix in VS Code, but you can also manually import it if you want. Then this time around, we won't say factory equals Spain factory. Instead, we'll say international provider. Again, I'll import it with this quick fix, and then invoke create and pass in our country enum value. So another thing we can do is to print out our country. And I'm simply going to print out the value of the country enum. Now, you might say, but whoa, you're hard coding it again, man. What's going on here? And that's a good observation, but I've got good news for you. Normally, this value will come from a user, either through a terminal or a user interface, or it might come via an HTTP request to a REST API or something like that. So when we say that the client logic will not change, we are referring to this logic. And then that country value will normally be passed by a user. But to stick to the simplicity of the abstract method implementation and to make sure that you exactly know how to implement it, I'm simply hard coding it there. But you can go ahead and type it in from the terminal or create a little user interface for you if you want to take it a little further. But without any further ado, let's test our code. I'm going to clear the terminal and then run Python 3 and execute our main file. And as you can see there, our country is England. Now you might say you don't like that country.england name there, and let's go ahead and change that to country.name. Okay, I'm going to clear the terminal again. Let's run it. And there it looks a little better. So the country is England. In England, they speak English. The English way of greeting somebody is hello. The capital of England is London, with a population of 8.9 million. And again, Tower Bridge, Buckingham Palace, and Big Ben as London's top attractions. Now we can simply change the country enum value to Spain, run it again, and in this time you'll see the country is Spain, the language Spanish. In Spanish they greet you like this, hola. The capital city of Spain is Madrid, with a total population of 3.2 million, and again Royal Palace, Prado Museum and Retiro Park as the top attractions. So as you can recall, the Abstract Factory design pattern provides an interface for creating families or related or dependent objects without specifying their concrete classes. In other words, the family of objects that are related, for example, includes English and London, and Spanish and Madrid. And then we do not depend on the concrete classes. In other words, here you'll see we are getting back the international factory. There we are getting back the language, our abstract base class language. And there we are getting the capital city back, which is also an abstract base class, and our abstract product B. So in our client code, we are actually depending on abstractions. In other words, this client code conforms to the dependency inversion principle that says that you should depend on abstractions and not concretions. So you might ask, what is the advantage to that? And the advantage basically links to another principle that forms part of the solid principles, the dependency inversion being the D in the solid abbreviation for the solid principles, and then the open close principle being the O in the abbreviation. In other words, this code will never change, right? That value will normally come from a user interface or a terminal. So that's why we can say that the client code will never change and is therefore closed for modification, but it's open for extension because you can have many more concrete factories that extends the international factory and implements its methods. At the same time, we could easily extend this international provider with more cases for different countries, and we wouldn't have to change anything in our client code. So that is why this code also conforms to the open close principle. As you can see, it's quite simple to implement the abstract factory pattern in Python. If you enjoyed this video, please go ahead and like it and subscribe to our channel. Till next time.